The first thing is pervasive encryption. Pervasive encryption has been around for a couple of releases now. It's been around for 4 or 5 years from IBM, at least. Chances are you're already starting to use it. You're at least testing with it. So while it is not required that you are actively encrypting your disk data sets, I would hope that by now most of you have at least started to test to see about encrypting. That means that you should have ICSF active, and ICSF is required for us to do our encryption. Chances are you already have ICSF active because you're using it when you're doing your testing of pervasive encryption. If, however, you have not started to look at pervasive encryption yet, I strongly recommend you look at the following red book. That is basically an introduction to how to do dataset level encryption on ZOS. And it goes through all of the steps you would need to do. So we're leveraging what IBM has already been available for 4 or 5 years now in a couple of releases with pervasive encryption, and we're just taking that to tape because IBM hasn't done that yet. Okay, so the demo I'm going to go through today is, first of all, how pervasive encryption for disk files currently works. I'm going to define the BES database. We call our encryption compression subroutine BES. And so how I'm going to define the BES database, define the parmlib members for the BES proc, and start the BES address space. At that point, we'll be able to compress and encrypt tape files. I'll analyze the output of those compressed files, the TMC data, the CKDS, and remember that Vantage can be used for a lot of these displays as well. All right. Okay, so good old ISPF screen. Okay, before I submit this job, I'm going to go into ICSF. Now, within ICSF, you may or may not be able to access ICSF yourself. That might be a function that is restricted to your security admins. On my mini system, I'm also the security admin. Currently, on my system, when I go into look at the CKDS, and I list all of the keys, I've only got 2 keys defined, an undefined and an AES test. If I want to submit a job using AES test, I can submit a simple IBGener. Step 1 deletes the file with an old delete, and step 2 creates a new one that makes it a copy of my active TMC. And then step 3 down here will be the actual listcat of it. But when I submit this job and I create this new file, when I go and look at that disk data set from 3.2, I can see that this file is being encrypted. It's an extended format and it is being encrypted. So this is just to show that I do have pervasive encryption active and defined and can be using it. Okay, next step is to actually define the database, the BES database. There is a sample JCL member supplied called BTE 10 DDB for defining your database. Now, I'm doing a delete of both the primary and the mirror, and then I'm going to define the primary and the mirror databases. So this step will simply define them using ID cams, runs just in seconds. Next is to define the PalmLib members. PalmLib members that I'm creating are in a data set called wittru01.bte.palmlib. There are multiple members here. The important one to note is the primary member is going to be 4 digits for your SMF ID and 4 digits for the name of the address space that's going to be running. So my mini system is called XE90, and I'm going to be starting up an address space whose step name, if you will, is called BES1. So there's a member called XE90 BES1. Now the PalmLib members that this system uses could be put in here directly, or I can point to a member that contains them. So if I want to have my BES database shared by multiple LPARs, and I'm talking about 12, 15, or maybe just 2 LPARs, by having them set up where they point to common members, I only have to have the keys defined in one place. My dynamic options only defined in one place, and my startup options only defined in one place, even though I might have an XE90 BES1, an XE76 BES1, a prod BES1, prod A, prod B, I can have multiple of them all pointing to these 3 members: startup, dynamic, and keys. Now, the startup is the startup parameters, and that's the name of my primary and mirror database and whether or not I want to exploit the zip. And I said yes to the zip, and I gave it the data set names that I had just defined using that vsam file. That's my startup members. Then there are some dynamic options, and dynamic options can be changed programmatically after BES has been started up. I don't have to recycle the BES address space. Talks about the log stream, which is where we would track logging information, what percentage will run on the zip, and the log detail. For what level of detail will I be logging to the log stream? On my system, I don't even use the log stream, so I've got that set to none. Now I've got the percent to run on zip set to 100, and I'll talk about that in a minute. Last are the keys. Here I'm defining 2 different keys. The first one is called clear, with an algorithm of clear. The compression is S9. S9 means ZEDC compression. We currently support S9 and S1. If you do not have a ZEDC because you're running on an old machine that doesn't have ZEDC enabled on it, you could set compression to S1. That takes a lot more CPU cycles. I would not recommend it, but compression, the ZEDC, is fast and wonderful. Then I have the algorithm, and again, clear is my algorithm, which means do not encrypt. I'm only going to do compression. So if the key specified was clear, I'm going to do compression only, no encryption. However, if the key specified was AES test, I'm going to encrypt with AES 256 level encryption, and I'm going to compress with ZEDC. Regenerate is something that is absolutely wonderful within our implementation of encryption. AES test is the name of the key. AES test for disk files is the name of the key itself. So the data is encrypted with the key called AES test. However, with tape encryption, AES test is a nickname. The real key stored in the CKDS, managed by ICSF, is going to be regenerated monthly. That means that for the next 30 days, I'm going to be using a key. After 30 days, I will start using a new key. And I don't have to change what's in my JCL, what's in my SMS storage class construct, with what's in my external security rule. They can all still point to a DS key label of AES test, but the actual key in the CKDS will be regenerated automatically on a monthly basis. And I'm going to generate 3 of them in advance. So those are my parameters. Those are all the parameters that I have. Next, I go to sys1 proclib, and I create my proc. My proc, I'm calling it, is BTER15, and my proc is as simple as a proc statement, executing the program, passing it a parameter that includes the member name, a step lib to my library, and a bez parms that points to my parmlib member, which I was just in, called witru01.bte.parmlib. And at that point, I'm ready to start running. So I start running my BTE R15 proc, but again, I want it to be thought of as bez1. So I'm going to start BTE R15 dot bez1 so that its name to the operating system will be bez1. Now, when it starts up, because the database was recently initialized, I'm going to get this message at the bottom. Enter my new passphrase, because this is going to be the passphrase that is used to encrypt the Bez database itself. Very, very important that you remember what that key is, because there is no backdoor for it. And of course, we get confirmation so that we have to enter it twice. I love the fact that the first message that's issued is, do not forget this passphrase. This passphrase is used to encrypt the database. There is no backdoor to it. Now, if I shut Bez down and restart it on the same LPAR, I don't have to re-enter the passphrase. There is an option to reset the passphrase, where you have to, of course, enter the existing passphrase followed by the new passphrase. I recommend that you change the passphrase for the database on a yearly basis. But again, it's strictly up to you. It's kind of like the master key for the CKDS database itself. Here you'll also notice, and I'm going to move this one to the top, zip exploitation parameter conflict. I don't have any zips on this system. So even though I had zip set to yes at 100%, it's saying There are no zips on this system, so I'm not going to be doing any zip processing. So at this point, my BES1 system has been initiated and some health checks have been started. But now I'm up and running. It's as simple as that. Now, within ICSF, when I had displayed the keys before, there were 2 of them. Now, there are 4 of them. One is the active one for AES test, and the other 3 are my pre-generated keys. One will be used next month, another will be used in 2 months, another will be used in 3 months. I'm always going to keep 3 keys defined in the CKDS ahead of the current one, so that this way, if I am creating tape files with encryption and the DS key label is specified as AES test, for the next month I'll be using this key. After a month I'll be using this key and a new one will be generated. In 2 months I'll be using this key and a new one will be generated, and so on. So the keys are rotated on a regular monthly basis, and I've always got at least the next 3 months to find in my database.
Hey, Russ, before you move on, there was a question, required parameters of the passphrase.
Requirements are very basic. If you want to put spaces, of course, it has to be within quotes. From SDSF or SysView, it gets problematic to use lowercase, though you could use lowercase. It does become problematic because of the way that SDSF and SysView always tried to uppercase everything. It can be long. I believe 255 is the limit. I use a simple one for my testing purposes, as you could see. But there are no requirements as far as it must contain so many numerics, so many alphas, special characters, nothing like that. Now, I've got my BES up and running. I've got my key defined. I'm ready to actually start encrypting data. I'm going to run this a couple of times quickly. The first time I'm going to run it is without the DS key label. All I'm doing is in step 1, I'm running a branch 14 to uncatalog my existing file. Then I copy my tmc.n to a tmc.copy, beginning with my high-level qualifier. Block full 32K block size. Then I do a quick compare to make sure that the data that I copied matches the original file. And finally, I do an IDCAMS print of the tape so I can see exactly what's on the data. 6885 only takes a minute to run. If I look at this file that I've just cataloged, you can see that I wrote the file. It wrote 463 kilobytes of data when it made the copy of the TMC. Program was IBGener, created just a minute ago. You'll notice I use the I command because I have used my ISPF configuration to allow I command. Of course, what I was displaying was the TI command. So you could use TI or I for that matter. Now I'm going to put, the only difference is I've got specified DS key label. So I'm creating the same file, but this time I'm going to be creating it with encryption. Now when I look at that in the TI display, you'll notice it's only 127 kilobytes in size. That's because of ZEDC compression. I cannot emphasize enough how wonderful IBM's ZEDC compression is, especially for high block size sequential files. And nothing says sequential files like tape, and block size can be as high as 256 if you're writing to an IBM TS7700, or 64K if you're writing to a standard one. I use 32K. And so I went from 4,653 kilobytes down to 127. So I'm at, what, 2-3% of the original value. Now, let's look at the output file. Well, the ZEDC hardware has been incorporated in all Z15 and 16 systems on the main chip itself. It is available as an extra chip on a Z14. But the Z15s and 16s, it's based on all of them. Now, this was the job that ran without the DS key label being specified. And if you look at the DS key label here, or the data here, when I dump the tape itself using the IDCAMS list, you can see TMS, CTL pound 1, TMS CTL pound 2 and 3, and the first couple of records, all of the records for all of the files, the whole TMC, and you can see it in pretty plainly. However, when I dumped this tape using tape encryption, a couple of things I want to point out here. First of all, when the tape was being opened, I came out with a message saying this file is being encrypted. And it's being encrypted with AES 256 and S9 compression, which is the ZEDC compression. I still created 146 total blocks of data because we do not reblock the data. So the original file, when it was created, had 146 blocks of data. The new one with encryption has the same 146 bytes of data. The difference is each block is significantly smaller. And you can see that when I ran the IDCAMS print. First of all, the IDCAMS print was done with a label equals 1, SUL. If the label is SUL, we will not attempt to decrypt the file. So here I specified a DCB of undefined LRECL 32760 because the data itself looks entirely different. Suddenly, instead of being able to see what the data was, I don't see my TMS CTL pound 1, pound 2 anymore. I don't see anything. It all is garbage because the data has been compressed and encrypted. And each block is significantly smaller. This first block is a hex 380, okay, which is a lot less than 32760 or whatever my block size had been. Also, when the job ran, I showed you this BES1 message saying that the file was being encrypted. When I read it for input in step 2, so that I could compare it against the original file, I have a message similar saying the file is being decrypted. So when I ran the compare utility to compare that the data still matched the original input data, which it did, the data was automatically decrypted for me. However, when I ran the fourth step and I had specified label equals SUL, you'll see that that message was not issued. There was no BES1 file being decrypted in step 4, like there was in step 3. The reason is because I had label equals SUL specified, the file was not being decrypted. The file, so the IDCAM's print is showing the raw, encrypted, and compressed data. Now, if I go into CA1's ISPF interface, okay, if I look at the one that was created without encryption, you can see that the data written was 100% of the bytes. So block count times block size, 100% of that data was written to the tape. When I ran it with compression and encryption, however, my byte percentage is now down to 3%. So only 3% of the data actually got written out. The other key factor I want to show is the BES key. The BES key says which one of the tape encryption keys was actually being used. In this case, it was BES key number 3. So if I've got multiple encryption keys currently in use, I've got one for payroll, one for warehouse, one for accounts receivable, I could see which key was being used for which application. Now, another way.
Russ, are you showing us that the compression was 97% on this data? So we only
Yes.
wrote out 3%.
Yep.
That's pretty good.
It was the TMC, which has got a lot of character data. And because a lot of the DSNBs are uninitialized, they're all hex zeros. So the TMC compresses really well, especially if it's not an actively used TMC. So yes, we were getting 97% compression. The ZEDC, again, since the ZEDC is on the motherboard, compression is fast. If you have used the Z compress option within ADR DSSU, you will have noticed a significant improvement in how long it takes to perform backups. The downside is that when ADR DSSU is using the ZEDC to compress the tape file that it's writing out, he's using the general processor. And so your CPU consumption skyrockets. With BES, we'll do the same ZEDC compression, but it's done in the zip if a zip engine is available. So you don't get that spike in CPU that you normally would get if you turned on Z compress within ADR DSSU. The other thing, old timers might remember the old adage, the fastest I/O is no I/O. Meaning if I want to improve the performance of a job, I should reduce as much as possible the number of IOs that the job is performing. The second fastest way to improve the performance of an IO-bound job is to decrease the size of the IO. And with ZEDC, the compression being 5 to 1, 6 to 1, 90 to 1, it's real easy to decrease the runtime. On a new Z16 box with zips available to it, we found that ADR DSSU backups of a sysres pack can be decreased by 30 to 40%. And that's the runtime. The runtime is that much faster. So if you've got long-running jobs that are doing a lot of I/O, that are creating large quantities of tape, compressing the data before it gets written is a wonderful way to improve the performance. In cache, it's not going to be any different, because if you've got a TS7700 box with Z compression, you're already doing Z compression before the data gets written to cache. The difference is the data being compressed before it's shipped down the channel or after it's been shipped down the channel before it gets written to cache. When you have to write down the full 256K block of data down the channel, it takes longer than it takes to write 40K down the channel. Just goes to, just a simple fact of life. It takes longer to write 256K down a channel than it takes to write 40K down the channel. And if I only am writing 40K down the channel, the job is going to run faster.
So Russ, that you will still have the same IO count as the number of blocks remains the same?
Yes, with CA1 flexible storage, the block count remains the same. If you turn on Z compress within ADR DSSU, the block count decreases because they fill up each block to 256K. We're not reblocking the data. So in this case, this volume with had the compression, I still wrote 146K, 146 blocks. So my block count was 146, and when I look at the volume that was created without compression, it had 146. So the number of blocks, what's starting on block 15 is still block 15. What's on block 18 is still block 18. If my application says, hey, fast forward to block 20 and read that block, it's going to be perfectly fine. The data is not reblocked for you. It's still that same block, which is why this works for products like
View, deliver, dispatch.
Yeah, view,
three.
deliver.
Mhm.
Yeah. So those products work fine. CA disk works fine. HSM works fine, because a block is still a block. It's just that now the block is much smaller. The larger the block size, the better. I was using 32K blocks. You can use 64K blocks. If your data is being written 80 by 80, okay, yeah, we might only write down 60 bytes instead of, or 20 bytes instead of 80 bytes, but we're still going to write tens of thousands of blocks of data. You're not going to see much of an improvement. When you have a larger block size, the compression is better, and so you get even a better performance improvement.
So Russ, if the zips are available, then does all processing for both ZEDC and encryption run on the zips? Or
Yes, it does.
Is there some GP usage? Okay.
There is some, of course, GP usage. because I/O can't be performed in the zip. So, for example, when I was running the IBGener, the reads are going to be done in the zip, the writes are going to be done in the zip. However, I'm only writing 3% of the data now because the compression was done in the zip, the encryption was done in the zip. So my general processor will actually decrease slightly because I'm only having to write 3% of the data. I'm also going to start up Vantage here, and I'm also going to go back to my job that I ran.
So Russ, just to be clear, because of the fact that we write the same number of blocks, but the data is much smaller, and therefore that's their savings that they're going to be seeing going forward.
Yes, you're only writing, a fraction of the data is actually being written. Again, if I log on to my mini system using Vantage, and again, I strongly recommend Vantage. It's the no-cost graphical interface that you can use to look at CA1 as well as BES database.
And not only that, Russ, for Vantage customers itself, they have access to this as well. So
Absolutely.
just be clear.
Any Vantage customer can also get this. Okay, tape resource management, tape management systems, CA1 flexible storage, and I've got my symmetric keys listed here. If I go and I look at my symmetric keys, I see that I've got AES test listed, and the BES key is listed as 3. So again, when I had shown you the CA1 information here, and I saw that this file was encrypted with BES key 3, in my Vantage display, I can see that BES key 3 is this BES label, and this is the name of the key that's actually defined. It ends with AA41. And AA41 is the first key that was established. So this is my current key. These 3, as I said, are future keys. And within my Vantage display, I can do a zoom on those encryption keys, and I can see which ones are my future keys. The key type is future. If I rotated these keys, and I could do it manually or a month from now, I'm going to start using this key ending in 6EZ41. And at that point, key 8ABLE41, my current key, it's not deleted, but it is made to be a past key. So it's not used anymore for creating new files. It's only used in order to read existing files. Now I can do a join between my volumes display and the BES database, or files display and my BES database, using the BES key as the common field, so I could get a list of all the files that have been encrypted with this specific key. If I wanted to get rid of obsolete keys and I wanted to find out if there are any keys that don't have active data encrypted on them anymore, I can get that kind of a display as well. If you've got a license for Vantage, the current release now gives you not only the tape management systems, which would include CA1, but it also gives you the ability to look at your robotic systems, your 7700, whatever.
That's
Right.
14.1.03. And there's a PTF available as well from the Vantage team, just published this week. So you have access to all the detailed information that Russ is showing as well within Vantage. Now, the Windows client will not provide that information. It's only within the web interface of Vantage itself.
Now, if you remember in my Bez Parms, I had defined clear. And so here I'm creating a tape that is going to be compressed only without encryption. So when I look at it, again, my byte percentage is 3. So I had 97% compression because I was doing the ZEDC, but the Bez key is 0. So this one was not encrypted, but it was compressed. And that was because I had run my job with the DS key label of clear. If I ran it with the DS key label, let's say of payroll, and payroll is not defined within the key structure within CA1, within Bez. So at that point, it ab-bends because the encryption request failed because the key label of payroll is not defined. So if I attempt to create a tape with a key that is not defined to Bez, the job is going to ab-bend. So if you are already using pervasive encryption, and you have pervasive encryption, the DS key label is specified via SMS data class or your external security product, you'll want to make sure that all of those key labels are defined within Bez so that if a tape is created using a DS key label that comes from someplace else, security rule or SMS data class, that will be taken into effect. The use of all of this compression encryption that I'm just showing you is only on 15.0, yes. Depending upon where you are, we had a very major upgrade for retention about a year ago that added some more retention options and also eliminated some options from CA1. If you've already made those changes, upgrading to 15.0 is a piece of cake. If you haven't done that, then there are some PP options that have changed because we've eliminated some TMO OPT members. TMS init will still run, but it'll come out with some warning messages if you've got them specified. Work files is obsolete, and there's a couple of others that are obsolete. Everything that we have discussed today is predicated on CA1 flexible storage, which means CA1 15.0. If you are using a different tape management system, including TLMS, this is not available for you. You're going to need to convert to CA1, though a TLMS clients can convert to CA1 without cost. So that's available to you, but it would be a conversion of your tape management system.
Russ, just one other point. You were pointing out just a second ago the key there that said payroll. I believe that was your label for the key.
Yes.
And you also mentioned, and you showed it, the future keys that you had there, right? So if you could just elaborate a little bit how that makes key rotation easy.
Right. With normal pervasive encryption from IBM, if I wanted to change the payroll key once a year, I would have to go out and change my SMS data class or my external security rule to say use key payroll 2023. Now use payroll 2024. Now use payroll 2025. So every time that I wanted to change my key, I would have to go out and change my production JCL that might have had the DS key label specified to point to the new key label, or my external security rule, or my SMS data class. with CA1 flexible storage, I've got my AES test, and that stays the same time after time after time. So even though the key that's actually being used within ICSF might change each time to a new value. This month it's AA41. Next month it's going to be the 6EZ41. The month after that it's going to be 3Dog41. Each month it's going to rotate to a new key. My JCL, my external security, my SMS data class, that never has to change. That can stay DS key label equals AES test forever. But what AES test translates to changes on a monthly basis. So again, my email is simply russell.witt@broadcom.com. I'd be happy to answer any technical questions. Mark Warren has put his name in. If you have any more marketingly related questions about Vantage, Mark is also the offering manager for Vantage.